Okay, so hello everyone. I'm Emil Stoychev. I'll be your speaker today. I'll introduce you to the webinar. Today we're going to talk about building one business applications with Silverlight and WCF data services. Just a few organizational stuff before we start. Slides, demos, and recording will be available on Silverlight Show within 2 days. All of you will receive an email with a link to the recording, slides, and the demos. So if you miss something or you have to go at a certain time, don't worry, we will supply with the recording after the webinar. We'll have a Q&A session after our talk. So please don't hesitate to ask questions through the chat console, and we'll try to answer as many questions as possible. If we can't handle all the questions due to time constraints or some other reasons, we'll try to follow up by email. I'll start with a few words about me. So I'm the Chief Technical Officer in Completed, the company which stands behind the Silverlight Show community. I'm also a co-founder of this community. I'm a Silverlight MVP and also a leader of the Silverlight user group here in Bulgaria. You can find me at emilsilverlightshow.net. This is my blog. You can also find me at Twitter. If you don't follow me now, you can do that after the webinar. So now let's see what will be our agenda for today. We will make a brief introduction to WCF. Then we will continue with OData, the Open Data Protocol. We will see what is WCF data services. We will see what an architecture of a service-oriented application should look like. Then we will continue with how to work with the data that's exposed through the data services, how to handle hierarchical data, how to filter, group, sort, and page this data, how we can apply create, read, update, and delete operations on this data, and so on. Okay, let's move on. WCF. I hope most of you are aware of what's WCF, so I have just one introduction slide. Basically, WCF is part of the .NET framework since version 3. If you're ASP.NET developer, you might have used ASP.NET Web Services, or also known as ASMX Web Services. These were prior of WCF, but now we have a more unified programming model for service-oriented applications. What WCF does is to provide a single model for building distributed applications. It has a message-based communication, either based on SOAP or REST. Today we will talk about REST-based data services. Now, to define WCF data services, we will first have to say a few words about Open Data Protocol. WCF data services are basically built on top of this protocol, so it's important to understand first the protocol and then what the WCF data service framework is about. So, OData. OData is a very basic protocol that works on HTTP and provides data sharing through open formats. First, it works with Atom or just XML, and second, it works with JSON to enable some AJAX applications. So we use OData to create REST-based data services. What OData enables us is to publish our data, either it's a SQL, either it's a data stored in a SQL database, or in XML, or in CLR objects, whatever. OData enables us to publish this data as a resource on the web. So we have our data stored on a particular data store, and through OData we publish this data on the web. All those resources are accessible by URI. So you can open your browser, type a URI, and get a certain entity or data from your data source. We can both read and edit data with simple HTTP requests. So it's not only about reading, but also updating, inserting, and deleting data. And all this is available only through the HTTP protocol. The data can be represented in multiple formats. The two currently supported formats are Atom and JSON. Depending on the application you're building, you can choose one of these formats, which one fits best to your case. OData basically targets a few scenarios. Today we are going to talk about how you can consume OData service from a Silverlight application, but you can also do that from AJAX application, or you can build some online service, or you can even build a mesh app. If the application that you're building is in one of those 4 scenarios, then probably OData is right for you. Let me now open a website. It's called odata.org. Here it is. This is the official website of the Open Data Protocol, and here we can find very good documentation, SDKs, and many other resources that are available for developers. Here are sample data web services. Let me open one. This Northwind test service, which exposes basically the Northwind database. I hope you are all aware of this database. So now when we open this Northwind service, we can see that it's available on the HTTP protocol, and it is accessible through this URI. What we have here are the entities that are exposed from this web service. So we have categories, we have customers, employees, orders. Those type of entities can be read or probably updated through this web service. Now let's see the data for, let's say, products. So I can basically type Northwind svc/products, and the service will return all the products that are available in this database. So here we see that we have a root element named feed, and this is how the data is exposed from the Open Data Protocol. Each feed contains a collection of entries, which is basically the entry of the data which we try to get. So from Northwind svc/products, we basically requested all the products from our database. So it returns a feed of entries which represent each entry represents one single product. For this product, we have several properties. So we have product ID, product name, category, unit price, and so on. These are basically all the properties of our product entity, but along with them, we also have some links. So basically, if you're exposing your data from a SQL server, and you have products in this database, these products are related to some categories. And also these products are part of a particular order. So with OData, we can see the links from one particular product to the category with which it is associated. We'll see how to open the category of this specific product later in this presentation. Now let's continue with our slides. So as I said, data is exposed via feeds, and the feed contains collection of entries. The entry contains list of properties, either primitive or complex. So for example, the product name is a primitive property. It is a type string, but it can also be of a complex type. So let's say one product has many suppliers, and the supplier is complex type. So probably we will have a link from product to suppliers. And the links property in the OData feed have a links element which contains the related feed. Every OData service have the so-called service metadata document. This document that describes the data model that we are exposing to this data service. We can get the service metadata document by calling Northwind SVC $sign metadata. So here I'm back in the browser, and by entering this address, I can see the full specification of our data model. So in this metadata document, we see what are the types of entities that it exposes. So we have category, we have customer, employee, and so on. Each of those entities have particular properties that are also part of this document. If we scroll down to the bottom, we will see what are the associations between the different entities. So for example, here we have an association named orders customers. This is basically the foreign key that we may have set in our database. And this foreign key is saying that we have multiple orders that are related to 0 or 1 customer. So basically one order contains 0 or 1 customer. This is the relation between those two entities, between the orders and the customers entity. Along with the association and the entities, we have also some other information, but probably these are the two most important things that are described in the metadata document. Knowing this, our client, let's say a Silverlight application, can understand to what type of entities it will talk and what are the relations between those entities. Let's go back to the slides. There are some URI conventions that we can follow to read and update data from our OData service. For example, we can address entries from our OData through the following schema. So we can say Northwind SVC / the collection name, or this is the entity's name, let's say categories, and this way we can read an entity set. So if we say Northwind SVC / categories, it will return all the categories that are found in the database. Optionally, we can type a key predicate, which is basically the primary key in the database, and thus we can extract a single entity from our data source. We can get even more specific and type a property of our entity. This way, the OData will return only the data for this particular property. Let's see that in action. So let's start first with extracting an entity set. So I can say product, and this will basically give me all the products. I can also say products 1, because I know there is a product with a primary key 1, and this will give me the information only about this particular product. I can go deeper in this entity. I can say products 1 / let's say product name. This way the service will give me only the product name. Here the product name is chai. Okay? So these are 3 different options of how we can address entities from our OData service. We can also get the links from a given entity. For example, if we go back to the browser and let's get back to products 1, we can see here that the entity products have a couple of links. So the product is linked to a category, it's linked to an order details, and it's also linked to a supplier. And here we have links to all those 3 different type of entities. So we can type products 1 / category, and this will return us only the category that is associated with this particular product. Let's go ahead and type this in the address bar. So products 1 / category. This gives us a feed which is of type category and contains all the information about this category. You see here we have category ID, category name, description, and even note that one. We have a picture which is of type binary. So it's not just a primitive type like string or int or whatever. We can also have binary data returned from our OData service. Okay, so these were the 4 different types of addressing particular entries from our data source. We can expand even more. So our OData service can not only take particular entities, so we can not only read particular entities, but we can also define some custom operation on our service. This operation can be basically everything we can imagine, and it depends on our business needs. But here is how we can call such service operation. So if you have a service operation named products by color, and it has a parameter called color, we can say products by color, question mark, the parameter name equal to the parameter value. This way, we will call this operation, pass the parameter, and it will return us the data that we want. Furthermore, we can expand with certain query string options. There are a number of them that are supported by OData. There are some basic ones like order by, top, and skip. These all are equal to the operators found in LINQ in .NET and also in the SQL database. So we can imagine that order by will sort the entries. Top will give you only the first n number of entries, and skip will skip n number of entries and give you the next one. Let's try some of these. So now I'm back in the browser, and I'll say give me all products. So this is basically the list of, you can see that there are many products here. I think there are 20 products. But I'll say, hey, just give me the top 2 one. Okay? And now by just entering this top in the URL, we got the first 2 products that are available in our database. And I can also say just skip the first one and give me the next 2. And now we see that we got product 2 and product 3. And again, by just entering such query parameters, we can sort and filter our result set based on these options. There are a couple of more interesting options that we'll look into. So the first one is expand. We just saw that a product is related to a category. But when I say, hey, give me just product, the first product, it won't vote the category. If we want to vote both the product and the related category, we can use the expand operator and thus vote the related entities to our product. We will see that in action just in just a few minutes when we are in our Silverlight demo. What else is supported by the Open Data Protocol? We can also specify the format. So this is the response type of our result set. In the beginning of this session, we said that the 2 response types that are supported are JSON and Atom. So basically, by specifying the format option, we can say, hey, service, give me these results in either JSON format or Atom. Another interesting option is the select option. By default, when we request a certain entity, it will give us all the properties that are related to this entity. By using the select option, we can limit the result set by reading only a subset of these properties. So basically, we can say something like this. like this, products 1, we can say select only, for example, the product name. Here are all the properties of the product. We can say, hey, just selecting the product name. And you see that now the OData returns only this particular property. We can also select multiple properties by delimiting the list with a comma. So we can pass a comma-separated list of properties that we want to extract from our service. Okay, let's see what other query string options we have. One of the most important options is the filter. This option basically allows us to filter our result set by certain rules. On this URL, there is a full documentation of all the supported filter query options. I have opened this address, so we can take a brief look at what is supported. So here you see there are many logical operators that are supported with the filter option. So you can say product filter price greater than 20. This will return all the products that have price property greater than 20. We have equal operator, not equal, less than or equal, etc. We have also support for arithmetic operators like add, submit, subtract, multiply, divide, etc. There are also a large set of string functions that are supported. So basically, everything that you can think of, there is a proper function available for it to filter your result set. So you can say substring of and thus filter the results by a particular string. You can say something like give me all customers which have company name that contains Alfred's in this property. And you can see that there are many other operators that are supported with the filter option. Here are a couple of date functions. You can extract only the day from a date time property, only the month, and so on. There are math functions available too, and so on and so on. So this list is available on OData.org, and you can check it out after the webinar. I've put a direct link to this page here, so you can check it out. And basically, these are the most important things from the Open Data Protocol in terms of how can we work with it, how can we read, update, how can we read and work with data, how can we page, sort, and filter data. Now let's get back to the WCF data services. This was about the OData, so we gave a brief introduction of what is the Open Data Protocol. Now we can return back to the WCF data services and see what is the relation of the Open Data Protocol and WCF data services. First of all, for those of you who are in the .NET framework from a couple of years, you may remember that WCF data services were first known as Astoria. This was the code name of the WCF data services, Then they were renamed to ADO.NET Data Services, and if I'm not wrong, they were finally renamed to WCF Data Services back in March 2010. From this moment, they are known by this name, and I hope Microsoft don't rename them once again. But we'll see that. So basically, WCF Data Services is a framework, part of .NET framework, which is based on top of the Open Data Protocol. It is a REST service that can be built on top of any linked data source. As I said to you in the beginning, it could be a relational database, it could be an XML file, a CLR object, or whatever. You can expose any data source, any linked data source, through a REST service with WCF Data Services. There are a couple of quant libraries that enable you to consume WCF Data Services from different types of applications. So there is a library for .NET, for Silverlight, for Ajax, for PHP, for Java. You can see that there are multiple quant libraries that basically enable you to consume such kind of service from any kind of application. Today we will focus especially on Silverlight. To this moment we saw that we can read data. With WCF Data Services we can also update data. This is achievable through standard HTTP verbs like get, post, put, and delete. So if we send a post request to a given resource, so we start a post request and send it to the Northwind SVC, for example, it will create a new type, a new resource. So if we send post customers, it will create a new customer object in our relational database. If we pass a GET request, if we execute a GET request, then we will read the resource. If we send a PUT, then we will update an existing resource. So if we send a delete, it corresponds to a deleting a resource. These are the 4 different types of HTTP verbs that are currently supported, and we can use them to achieve creation of a resource, reading a resource, updating or deleting a resource. So here is how a service architecture looks like when we use the WCF Data Services. On the bottom, we see the type of data source that we can use. A relational database, CLR classes, or just any type of data source. On top of that, we have the data service providers. So basically for a relational database, this is Entity Framework. For CLR classes, this is a reflection. And for other types of data source, you can build your own data service provider. On top of that, we have the data services runtime, and they expose our data through Atom and JSON. After that, we have the OData client libraries that are available for Java, Ajax, PHP, Silverlight, etc. for Windows Phone, of course, and we can consume the data service with the help of these client libraries. From the other side, those client libraries communicate with the WCF Data Services on the top of the HTTP protocol. So you can see here how everything is standardized, and it can be easily consumed from any kind of application. So we can build a Silverlight application, it can consume a WCF Data Service but there might be also a Java application or an iPhone application that can consume this data service. Okay, so this was about the architecture. One thing to note here is, after it's all web services that we will access from our Silverlight application, we need to be aware of the cross-domain execution. So basically, if our application is stored on services.control.com and acts a web service which is on services.control.com, it's okay. But if the protocol is different, if the subdomain is different, if we have a different host or different port, then we should place the client access policy file in the root directory of our web server. This is pretty standard, so it doesn't matter whether you use WCF data services or other type of web service. You have to place this XML file in your web server root directory so you can consume the data service. Okay, so this was the introduction of the OData and WCF data services. Now let's see how we can work with this data from a Silverlight client. Now I open Visual Studio. Let me close this and bring up Visual Studio. I'll start by creating a new project. Let's say I'll need a new Silverlight application, and I'll call it WCF Data Services Sample. I'll just go here and click OK, leave the default options. And here in our web project, I'll first start by creating a data source. I'll use Entity Framework to create an entity data model that will later consume from our data service. So I'll start by add new item, go to data, and choose ADO.NET Entity Data Model. I will link this entity data model to a local Northwind database. So I'll call this Northwind data model. I'll choose to generate my data model from a database, and I'll choose my Northwind connection string from here. These are pretty standard stuff. I hope you already know all of these. For the demo, I'll go ahead and select all tables that are related to Northwind database. So I'll just keep the ACE.NET tables, and I'll go ahead and click Finish. So the Visual Studio wizard just created our entity data model, and now we are ready to expose this data model to our WCF data service. Okay, we see that we have orders, customers, order details. Down here we have employees, etc. Okay, so now to add a WCF data service, I'll go ahead again and go to add new item, go to the web category and scroll down to WCF data service. There's a template for that in Visual Studio 2010, so we can use it pretty fast and easy. I'll call the service Northwind, and here the template contains a Northwind SVC and Northwind SVC.cs file. In this Northwind SVC CS file, there are a couple of commands what we should do to expose our data as a service. First thing to do is here to put our data source class. We just created our Northwind data model, so it created a Northwind entities class. So basically I'll say Northwind entities, and now I'm ready to open this web service and to see that our data is actually exposed to the web. Just one thing that we should note here is that by default there is no public access for any of our entities. So the first thing to do is to give access to any of the entities that we would like to use. So here in the initialize service method, we can say config.set entity set access rule, and we can say products, because we have entity called products, and by entity set rights enumerable, we can choose the permissions that we would like to set to this resource. Just for the demo, I'll use the all access rights, but you can see here that we can give only read access, only write access, and then we can be more specific. For example, we can set you can only read multiple entities, multiple entries from this entity. You can read only a single one. You can only append data, delete data, replace, merge, and so on. Now for the demo, I'll just use all. And now I think we are ready to see our data service. I'll just build this project and say Northwind SVC view in browser. So now you see that the only entity that's exposed from our web service is product. And I can go ahead in the address bar and say /product. And now I get a complete list of product entities that are available in our database. So you can see how simple it is to create such data service just by adding your data source, and by adding the data service data template, you're good to go and you have the data service created. This is everything that you need to do on the server side to expose your web service. Now, if you to consume this data service from our Silverlight application, we'll have to go on our project, right-click and choose Add Service Reference, just what we would do with any web service that is available, that is publicly available. Here I'll click Discover. I'll select the Northwind SVC. I'll just leave the default namespace and click OK. And now we are ready to use our data service. I'll bring up main page .cs, and in the constructor I'll say probably service reference 1 Northwind entities. This is the class that was just generated once we executed that service reference wizard. This Northwind entities class is actually our context that is available for querying and manipulating data. So I'll name it context. The only one parameter that we need to provide is our service URI. Let me copy this URI from here. Okay, and I'll say new URI, and I'll give here the string. Okay, so the Northwind entities is our major player in our application. This is part of the tools that are shipped with the WCF data services. So by creating this service reference, we can now go ahead and say context dot something. Here are multiple methods that are available for querying and updating our data. Let's go back to the presentation and see what we have in this WCF services quant library. So the main citizen in this library is the data service context. It is the runtime for our data service, and one of his key roles is to maintain state between interactions. So if you update data, it will help you track any changes and so on. Another thing is the data service query. It allows us to execute a link query against our data service. You have to note that there is a limited support for link. For example, if you use the group by operator in link, you should know that it is not available in WCF data services. There are many other operators like join, for example, which is also not available in data services, but basic link queries, you can execute them against your data service. With this data service query, it will return you an enumerable, no matter whether there is only a single entry in your result set or multiple entries. It will always return an enumerable. There's a query operation response which you can use to check for errors and to get the data from this data service query. Let me demonstrate this with code. So I'll say var query equal to context dot product dot let's say where. I'll just list all products which have product name that starts with, let's say, C. I think there should be a couple of products starting with C. Okay, and I can easily cast this to a data service query of product, because I know that the result from this will be a product. Okay, so now from this query I can say begin execute, and I should pass a callback, async callback. So I can say basically something like that. The other parameter that we need to pass is the state. I'll just pass no. And here in the body of our callback, what we need to do to get the data is call query.endExecute. And by passing the event args or the async result that is available in our callback. And you can see that this is a enumerable of products. So I can say var p in data, and you can now see that p will be actually a local variable of type product. And here is how we can load the data from our data service by using a data service query. However, this is probably the manual way of doing it, but there we have a more granular. We can set different type of options, just what we saw in the first of our presentation, where we can filter, order, etc. So we can basically say, after this where we can say order by something, and again we can cast it to data service query. So this is how we can execute a direct link query against our data source, our data service. There are some more convenient ways in Silverlight where how we can load data, and this is by using data service collection. Data service collection is basically an observable collection which provides some notifications for adding and removing entities and ensures that objects that are part of this data service collection will be tracked by our data service context. I'll bring up a project that I've already done. Here I have again our web project, and I have a Northwind SDC, which is the same service that we just built, but I've given some access rights to some other entities as well, so with categories and products. And here I have a Silverlight application that have a very simple view. We have a combo box for selecting particular categories, and we have a data grid that will list the products from a given category. Let me first run this project and see how it looks like. Oops, I should have commented this code. Sorry about that. Let me run that again. Okay, so here we have a combo box that lists particular products from this category, and I have some buttons here on the top just to save and load some more products. Let's see this in code. So the first thing is to create this Northwind entities, just as we saw just a minute ago. And then we have methods for loading categories and products. Here in the load categories method, you can see that I have a query that selects category and orders them by category name. Here I create a new data service collection, and by calling data service collection.load async and passing the query, I'll load all categories ordered by category name. You have to handle the load completed event so you can get the result set from this call to the data service. And this is probably the preferred, my preferred way for loading data by using data service collection, because this way I know that all my objects are in sync, they are tracked by our data service context, and any change that we do on this data source will be reflected back to our database once we call save changes. I see that we are running out of time, so I'll just quickly go through the next slide. One thing that I've shown you in the first part of our session was lazy and deferred loading. This was with the expand operator. So with expand we can load additional or linked entities. So we can load, for example, all categories and expand all products for all categories. This will basically return us a result set with all the categories and all products. Here are some options that we can use with the data service SDK. They all are in the demo, so you can take a look at them after the webinar. One important thing that I would like to talk about is batching operations. So let's get back to our demo. For example, here we have 2 products, and I can go ahead and edit the data for this product. Then I can go ahead and edit the data for this product. So now once I click Save, the client library will have to change both these entries. We'll have to send them back to the data service and update them accordingly. We can either do that in a single call, or we can do that only we can do that on multiple calls. Let's see this in code. So here in the Save Products method, it will be code once we click the Save Changes button. Here we can say context.begin save changes, and here we can pass a parameter. Let me go out of debug mode and see what are the different options. By default, we use the save changes options .none. So this will go to the execute 2 different calls to the data service, one for each update. We can use batch, which will basically execute all the update methods on one single call, and continue on error and a replacement update will also execute. For example, continue on error will execute the changes in one call, and will continue if one of the calls throws an exception, for example. So this is about batching operations. It's very important to understand it because it reduces the round trips to the server, and it helps you maintain the state in your data service and apply all the changes all at once instead of calling the service multiple times. So in most of the cases, I would advise you to use save changes options.batch and save all changes at once. Okay, we can filter data by using the where clause in link, or by using the filter option in the URI. You can sort data by using the order by clause, or by specifying the order by option in the URI. One of the things that is missing in WCF data services, or actually it's missing in the Open Data Protocol, is grouping. Currently, there is no way to group data on the server. You can do some things, you can probably extend the Open Data Protocol to support grouping data, but this won't be part of our talk today. One workaround for this is to create, for example, a stored procedure in your SQL server and use a service operation to call this stored procedure and return the group entities. Paging, as we saw, we can do that by just using top and skip in OData, or take and skip in link. We can set some page limits to our data source. So even if the user specify top 10 in the URI, we can set a page limit of, let's say, just 2 entities. So this way, even the user set top equal to 10, we will return only 2 entities, and I will just quickly show you how to do that. This is done in the data service. Here in the initialize service method, we can set, say, config.send entity page size. So for each particular entity, we can set a limit for this entity. Basically, this will return us only 2 products on each request. Okay, and with this, I think we're finishing up with the slides. And I'll just make a brief summary of what we just talked and open up the Q&A session. I hope you have some questions that I can answer quickly. So, what are the things that you need to remember? First, OData. It is a protocol for data sharing, and it exposes some data like a REST-based service. This is the only thing that you need to remember for OData. Everything else are just details, and you can go ahead to OData.org and learn more about it. WCF data services is just a framework on top of OData. There are quant libraries for many different platforms. Today we looked at the Silverlight quant library, but you can also use data services with PHP or Ruby or some other technologies. You can easily query data, sort, filter by the help of data service collection. It's a generic collection. It inherits from observable collection that I believe most of you are already aware. In data services, just use data service collection to keep track of everything that is updated so we can link it up with the server. With the paging, there are both quant queries and service limitations. These are two different ways where you can apply some paging for your data. Okay, so now let's see whether you have some questions that I can handle. Okay, let me start with the questions. Okay, so the first question is by Brian Paul. The question is, when querying by URL, what if the entity has a composite key? For example, product key is customer and product ID. How would you express that in the URL? That's a very good question. You can do that pretty easily. So, for example, you're saying that your product has a composite key. So instead of just applying, let's say, 1, which might be the product ID, you want to get data by 2 keys. You can do it like that. So you have to pass customer equal to, let's say, 1, and product ID equal to 1. So this will go to the SQL database and say something like this. Let me bring up a notepad here. So this will basically say select zvezda from star from products. Sorry, select star from products where customer equal to 1 and product ID equal to 1. So this is how we query entities which have composite keys. Okay. The next question. Is all data considered secure? Since you pass all query parameters in the URI, what if quant app passed a credit card number in a filter? Well, you can always encrypt your URLs, and also you can provide security. So you can secure you can set security by entity. You can also supply some methods that where you can test whether the user is authenticated or not. Let me just give you a quick example of that. Let me uncomment this code. So you can say every time you query categories, you can check whether the current request is authenticated, and then you can see what you can do. You can either throw exception and say, hey, you can get categories only when you're authenticated, or otherwise I cannot give you the list of categories. About your example, if you pass the credit card number, well, I would surely not do that with data services, but by using some encryption, you can still we can still say that it might be secure to do that. But you know, with credit card details, you should always be very very careful. Okay, the next question is, can you give me an example of state you would pass into begin execute method that you just said to no? Okay, sure, I can give you an example. So here in the begin execute, you can pass some state. For example, you can pass the context, because if we didn't use a lambda expression here, but we use another method that is, let's say, handle, what's that, handle products, async results. If you do it that way, handle products, then we will need some way to call end execute, but the query is no longer available. That's why we can say the state would be query, and here from the e.async state we can cast that to data service query of product. Okay, and then we can call the end execute methods. So this is an example of how can you use the state parameter in the begin execute methods. Okay, and let me handle one last question, as we are running out of time with almost 20 minutes. The question is, if you want to display more than 2 entities in a data grid, do you need to create a view model? Well, that's a question that is related to a model view model pattern. Basically, you can do it either way. My preference is to use the MVVM pattern, and that's why my demo was based on this pattern. But you can either use view model or not. It's just a preference. Okay, with that, I'll close the Q&A session. Sorry we don't have more time for questions. I'll reply by email to all of the outstanding questions, hopefully within 2 business days. Thanks for attending. I hope you enjoyed this talk and you learned what is OData, how can we use it with WCF data services, and hopefully you will be part of our next webinars. So follow me on Twitter, follow Silverlight Show, just to be up to date with all the Silverlight news and all the events and webinars we organize. Thank you for joining. Bye bye.